Ethiopian Air Flight 610 crashed into the sea shortly after takeoff from Jakarta, Indonesia. 5 months later, Ethiopian Airlines Flight 302 experienced problems shortly after takeoff and crashed. The type of aircraft involved in both accidents is a 737 MAX 8 manufactured by Boeing.
The 737 MAX. No commercial aircraft in aviation history has probably generated more interest and become a conversation topic in general households as this one.
Was Boeing aware of the defects in the MCAS system, which it failed to disclose to the FAA at the time the aircraft was in development and certification?
Senator, as you know, the MCAS development occurred over a lengthy time period, about a 6-year development program of the MAX. We have learned from both accidents, and we've identified changes that need to be made to MCAS. We did, during the development process, follow our certification standards and long-standing industry standards behind the MCAS design, but clearly we've learned.
So what does the Maneuvering Characteristics Augmentation System, or MCAS, on the Boeing 737 MAX actually do? First, it's important to understand what angle of attack means. The angle of attack is the angle between the direction of motion of the aircraft and the direction of the oncoming airflow. It is measured by 2 angle of attack sensors, one on each side of the aircraft's nose. The MCAS activates automatically when the angle of attack is high. It requires that autopilot is off, the flaps are up, and the aircraft is steeply turning. When MCAS is activated, it moves the horizontal stabilizer trim upward at 0.27 degrees per second, up to 2.5 degrees and 9.26 seconds at a time. MCAS pushes the jet's nose down to reduce the risk of stalling. The system gets deactivated when the angle of attack is sufficiently lowered, usually when pilots override with manual trim. So how would such a system result in an accident? Let's assume that the aircraft has an actual angle of attack of 10 degrees. However, an erroneous angle of attack sensor detects this as 40 degrees and commands the trim to stabilize the nose, supposedly to reach 0 degrees. Instead of a correction by 10 degrees, the system makes a correction by 40 degrees, which now means the aircraft has a negative angle of attack of minus 30 degrees, causing it to accelerate into the ground. Though the 737 MAX began flying commercially in May 2017, it was grounded in March 2019 following the Ethiopian Airlines accident.
We're going to be issuing an emergency order of prohibition to ground all flights of the 737 MAX 8 and the 737 MAX 9 and planes associated with that line.
The Federal Aviation Administration cleared the aircraft to return to service on November 18, 2020, subject to mandated design and training changes. Canadian and European authorities followed in late January 2021. The MCAS software has been modified and now uses 2 angle of attack sensors, not 1. The MCAS also only activates once rather than multiple times when a potential stall is signaled by both the angle of attack sensors. Importantly, pilots will now be trained on the operation of the MCAS and management of its problems. Interestingly, it looks like Boeing's problems are far from over. A 6-week audit by the Federal Aviation Administration found dozens of problems throughout the manufacturing process at the plane maker and one of its key suppliers. The air safety regulator initiated the examination after a door panel blew off a 737 MAX 9 during an Alaska Airlines flight in early January. 5th January 2024, Alaska Airlines Flight 1282 was a scheduled U.S. domestic flight operated by Alaska Airlines from Portland International Airport in Oregon to Ontario International Airport in Ontario, California. Shortly after takeoff, a door plug, which is a structure installed to replace an optional emergency exit door on the Boeing 737 MAX 9 aircraft, blew out, causing an uncontrolled decompression of the aircraft. The aircraft returned to Portland for an emergency landing. All 171 passengers and 6 crew members survived the accident, with 3 receiving minor injuries. The door plug relied primarily on 2 pairs of bolts at the top and bottom, as well as metal pins and pads on the sides to stay in place. When investigators recovered the plug from a backyard in Portland, they found that the plug itself was largely intact. The bolts, though, have not been recovered. Experts have said the visual evidence suggested some sort of bolt failure. One possible explanation is that vibrations could have loosened improperly tightened nuts on the bolts or severed the so-called cotter pins, securing some of the nuts in place. And a school teacher in Portland has become an overnight celebrity after finding the missing door plug in his backyard. The Federal Aviation Administration's 6-week audit of Boeing and Spirit Aerosystems found multiple instances where the companies allegedly failed to comply with manufacturing quality control requirements. To hold Boeing accountable for its production quality issues, the FAA has halted production expansion of the Boeing 737 MAX.
We have a communications task with all of our customers. Moments like this shake them to the bone. They have confidence in all of us. They do. And they will again. But we're going to have to demonstrate it by our actions, our willingness to work directly and transparently with them, and to make sure they understand that every airplane that Boeing has its name on that's in this sky is in fact safe. And we will see our way through that. But we need to know we're starting from a very anxious moment with our customers. And we simply have to deal with that reality.
Here's wishing for a time the skies become safe again.